Welcome to the basic course of strength of material. In this class, we are going to discuss about torsion loading. Myself, Karthik L, Assistant Professor, Department of Mechanical Engineering, Hindustan College of Engineering and Technology, Coimbatore. So, torsion plays a major role in each and every applications. So, first we are going to look about a torsion of circular shaft. So how it works? A shaft is said to be in torsion when equal and opposite torque are applied at the two ends of the shaft. The torque is equal to the product of the force applied, which may be tangential at the end of the shaft, and the radius of the shaft. Due to the applications of torque at the two ends, the shaft is subjected to a twisting moment. This causes shear stress and shear strain in the material of the shaft. So this animation will give you a clear picture about the torque or twisting moment. So the definition is a twisting or wrenching of a body by the exertion of force tending to turn one end or the part about a longitudinal axis while the other is held fast or turned into opposite direction. So once we're going to fix the structure or the shaft on the one side, and we will try to twist the other end. So it may you may see the variety of applications in automobile industries also. So next one is a torque on turning moment or twisting moment. So how this torque works? So we're going to discuss about the twisting moment and the other things, how it happens. So in factories and workshops, the shaft is used to transmit energy from one end to another end. Let me take a simple example. In automobile industries or automotive components, you take a lorry or heavy vehicles. You have a propeller shaft. It transmits power from engine to the crown wheel, differential unit. So there is a possible to twist moment. There will be a possible of twisting which will happen once we transfer the energy from another. So to transmit this energy, the turning force is applied either to the rim of the pulley or keel to shaft or to any other suitable points at some distance from axis of the shaft. The moment of couple acting on the shaft is called as torque or turning moment or twisting moment. That's what we have mentioned. A shaft is said to be in torsion when equal and opposite torque are applied at the end of the shaft. Okay, the torque should be the equal. It should be equal to the product of force applied and the radius of the shaft. That's what we have explained. And the next one is. So let me take a simple example for this torque. Let me take a shaft. Two equal and opposite force. This makes a couple. Okay, so look at this picture. The force on the left and the right, which will be acting opposite to each other. So here we may call or we may mention the torque is equal to turning force into diameter of the shaft. So torque is mentioned as T, and for turning force F into the diameter of the shaft should be capital D, or else we may call it as 2 into R. Whereas T is the torque and F is the turning force and S should be the radius of the shaft. In general, the unit of torque is mentioned in Newton millimeter or Newton meter, or else if we go for higher values, then we may call it as kilonewton millimeter or kilonewton meter. Next, angle of twist. So how this torque will occurs? When a circular shaft is subjected to torsion, the shear stress are set up in the material of the shaft. We have to determine the magnitude of the shear stress at any point of the shaft. Consider a shaft fixed at the one end and free at the other end. Let the center line of the shaft. Let me focus on the center line of the shaft. Once we apply a force on this shaft, or the shaft is subjected to a torque, at the free end. As a result, the shaft at the free end will rotate clockwise and every cross section of the shaft will be subjected to shear stress. Then the center point of the shaft at the free end will shift to a new point. Let me take that point as D, then it will move to a new point called D dash. Or else here they are mentioned as A, or the new point as A dash. So that's why that's it they have explained. When the shaft is subjected to torque, a point A on the surface of the shaft, it comes to A dash position. The angle A dash at the center of the shaft is called as angle of twist. So the angle of A dash equal to theta, that is called as angle of twist. The angle of twist is generally measured in terms of radians. So let me see this picture. So this is a circular this is a circular shaft. Let me take the center point. Let me take the center point as a O, and we might notice any one of the point at A. When we apply a force over the shaft, it rotates clockwise. Then it will changes the position from A to A dash. This deviation is called angle of twist. The next one is shear stress in shaft. So what is meant by shear stress in shaft? So whenever we going to apply a load over the shaft, or whenever it's subjected to torque, there will be equal and opposite couple. Those axes coincide with the axis of the shaft. When it happens, this subject is purely in torsion at any point in the section of the shaft. There the stress will induced because of this torsion, pure torsion. So that stress is called as shear stress in the shaft. We may mention as in terms of tau. We may mention in terms of tau. We move on to strength of the shafts. So whenever we try to select a shaft for a particular application, we need to know about the strength of the shaft. Without knowing the strength of the shaft, literally we may not select, because based on the applications it might vary. For example, if we use the shaft in automobiles or automotive industries, it should withstand maximum torque or maximum power, and also it transmits the power from one pulley to another pulley without any break. That is the term which may be called as strength of the shaft. So we need to study about the strength of the shaft once we are going to apply for each and every applications. So here the shafts may be into two categories. One is solid circular shaft and another one is hollow circular shaft. For solid circular shaft, how do we calculate the torque value is with the help of this equation, our expression T equal to pi by 16 into tau into d cube, whereas capital D is the diameter of the shaft and tau is the shear stress in the shaft. The hollow shafts, hollow circular shafts, again the maximum torque is given by T equal to pi by 16 into tau into capital D power 4 minus a small d power 4 by capital D. Here for the hollow shaft we have two diameters, one is outer diameter and as well as the inner diameter of the shaft. So the equation slightly changed for hollow circular shaft. With the help of this equation we are going to calculate the torque, maximum torque for solid shaft. And here let me discuss about some of the assumption while we follow the theory of torsion. Okay, once we are going to calculate the shear stress in the circular shaft, or which may be subjected to torsion, we need to consider these things. The first and foremost thing is the derivation of the shear stress produced in the circular shaft which is subject to torsion is based on the following assumptions. The first and foremost assumption is the material of the shaft is uniform throughout the length. Throughout the length is uniform in the sense that there will be a homogeneous nature. That's what they have explained. The next one is a twist along the shaft is also uniform. Once we apply a load or a couple, the twist which will happen will be uniformly throughout the shaft. And the next one is a shaft of uniform circular section throughout the length. There will not be any deviation. And the cross section of the shaft which are plane before twist and remains plane after twist. So the plane is also same, remains and after the twist. And all radii which are straight before twist remains straight after twist. These are some of the assumptions of the theory of torsion. Once we apply for a theory of torsion or pure torsion. Next we discuss about the polar moment of inertia. The polar moment of inertia is nothing but we already know the formula T by J equal to tau by R equal to C theta by L. This is the torsion equation. From that we have derived the torsion equation. So the J plays a major role. So J is nothing but the moment of inertia of the plane with respect to axis perpendicular to the plane of the figure is called polar moment of inertia. We need to calculate the section value with the help of this following expression Izz equal to Ixx plus Iyy equal to J. From the lower classes or from the your first year classes, you may discuss about this equation in engineering mechanics. So by deriving this, you will get pi by 64 into d power 4 plus pi by 64 into d power 4. Finally, you will get pi by 32 into d power 4 for calculating the polar moment of inertia for the circular shafts. This is from the perpendicular axis theorem. And next we move on to the theory of torsion and a torsion equation. So this picture will clearly gives you an idea about a torsion. See, look at the picture. The one end is fixed and another end is once we apply a load on it, it will twist or it will deviate from its original position. So first position, it starts from, let me take A and it move on to the A dash. So consider a fixed shaft at one end which is subjected to the torque at the other end. Let T equal to torque and L equal to length of the shaft and R equal to radius of the shaft. And next, as a result of this torque, each and every cross section of the subject will shaft will subjected to shear stress. Yes, once it deviates from its original position, it changes its nature. So the shear stress automatically will occur. The line CA on the surface of the shaft will deform to CA dash and OA and OA to O dash as shown in this figure. Let the triangle ACA dash equal to shear strain and AO A dash equal to angle of. Move on to the torsion rigidity. The torsion rigidity is nothing but let me take the twisting moment procedure will produce a twist. The twist may be calculated in radians and the length in L. So the equation should be T by J equal to C theta by L. Let me we all know about that. T equal to torsion, J equal to polar moment of inertia and G is modulus rigidity, angle of twist and L equal to length. The given shaft, the twist is therefore the proportional to the twisting moment T. If a beam which is bending, if we calculate the bending moment of the beam, once we apply a load on it, there will be a deflection. So the same manner, the torque will be produced in the shaft. Then the quantity Ci stands for the torque required at a twist of 1 radian per unit of the shaft. The quantity corresponding to the similar EI in expression for the deflection of beam, EI is modulus of rigidity, or else we may call it as a flexural rigidity value of the shaft. Let me move on to the basic problem regarding this torsion. We'll be calculate the diameter of the shaft to transmit 10 kilowatt at a speed of 15 hertz. The maximum shear stress should not exceed 60 megapascal. They have given the shaft diameter. They may calculate the shaft diameter. They have given the power as 10 kilowatt and at a speed of 15 hertz. the speed is also given and power is given, and the maximum shear stress is given. We need to calculate the diameter of the shaft. So we let me take the solutions. First, let me try note down the given data. Power equal to 10 kilowatt and speed n equal to 15 hertz, which is equal to 15 cycle per second. And let me converted to RPM, 15 into 60 RPM. So we will get the value of 900 RPM and tau equal to 60 megapascal. Let me know the formula for power equal to P equal to 2 pi nt by 60. Since we know all the values other than the torque, we apply the value T equal to T equal to 106.10 Newton meter. Now we know the other formula for torque, T equal to pi by 16 into tau into d cube. So T equal to 106 in 10 to the power of 10 in 10 to the power of 3, that is equal to pi by 16 into 60 into d cube. Whereas we don't know about the d cube. We calculate other things, we will get the d cube equal to 9006. Then by taking the cube root, you will get the T equal to 20.80 mm. This is what the shaft diameter. Move on to the next problem. Example 2 is a shaft of 60 mm diameter rotates with 180 RPM if permissible stress is 100 megapascal and torque and power in kilowatt. So the given data is the diameter is 60 and it rotates with 180 RPM and permissible stress is 100 megapascal. So we need to calculate the torque as well as power. We know the formula for torque, T equal to pi by 60 into tau into d cube. By using this term, by applying the value, we will get T equal to 4240 Newton millimeter. Next, we move on to calculate the other thing. P equal to 2 pi nt by 60. Since we know the torque, apply the value in this power equation, you will get 79922.11 watt. So 79.92 kilowatt. So this is what and thank you for this. We will meet in the next class regarding the higher problems of torsion and twisting moment. Thank you.